This lesson on limits is a new concept, a new notation. A limit is used to describe what happens to an expression as the value of the variable approaches a certain value. So I've got an example here. How I would read this is, what is the limit of 2x plus 1 as the x value approaches 3? Okay, approaches means gets really close to 3. Okay, and the limit really means what's the value of 2x plus 1. Okay, what we mean by approaching 3 is that the x value here gets closer and closer to 3. Okay, from below, so 2.5, 2.7, closer to 3, and from above. And we want to see what happens to this function value. Okay, so just to practice what this notation means, the second one we would say, what is the limit of x squared minus 5 as x approaches 2? Okay, it's asking us that question. Okay, similar thing for this one. What is the limit of the value of f of x as x approaches 5? Okay, or this last one, what is the limit of the value of 1 on n as n approaches infinity? Okay, so let's just look at this last one. The limit as n approaches infinity, so that just means that n is getting bigger and bigger. So I'd substitute in some values and see what happens. Maybe I'd put n equals 1000. Okay, and I'd see that 1 on n is 1 on 1000. Okay, that's a pretty small number. What if I made n even bigger, approach infinity closer? Okay, n equals infinity. Okay, 1 on n. Correction, n is a million. 1 on n would be 1 on a million, 1/1,000,000th. Okay, a really small number. So as n gets bigger and bigger, 1 on n gets closer and closer to 0. Okay, so it's essentially going to end up at 0. Okay, more or less 0. Okay, so the limit will be 0. Where we have fixed values, okay, such as in this first example, where x is approaching 3, what we'll do is approach it from below and above in a table, okay, to make sure we're looking at it from both sides to see what value it'll approach at x equals 3. Okay, so I'll substitute in 2.5 into this equation, so 2 times 2.5 plus 1. Okay, in this case, I'll get 6. Okay, and I'll do the same thing for all these other points to see what 2x plus 1 approaches as we get closer and closer to 3. So what I can see is as we get closer and closer to 3 on both sides, okay, this is getting closer to 7 and this is coming down closer to 7. So I would say that the limit of 2x plus 1 as we get closer to 3 would be equal to 7. Okay, that's essentially what we're exploring down here. Okay, you might think, yeah, I could have just substituted in 3 and found that. 2 times 3 plus 1. Yep, and I agree. Okay, so to find some of these limits, we could just simply substitute in that value. Okay, so in the second example, okay, so for continuous functions where they don't have asymptotes, so they don't have anything going like this with asymptotes here, or they're not hybrid functions where it's a quadratic and then changes to a sine wave perhaps halfway through. Okay, we can find the limits just by substitution. So if I was trying to find a limit of x squared minus 5, all I'd do is basically substitute 2 into here. 2 squared minus 5, and I'd get a 1. Okay, if I had the graphs of these things, okay, I could just read it off the graph. So for this example we just looked at, I'd find where x equals 2 is and read off the graph that the limit's -1. Or in the previous example, when x equals 3, look up here, there it is at 7. Okay, so you can have a go at these sorts of questions where you're essentially just substituting in the x value to find the limit. Unfortunately, it's not always that easy. Okay, if I tried to investigate the value of this limit here, whenever I write limit, the x approaching 1 should be below, and it all should be in the 1 line. So I'll try direct substitution here. I'll try and substitute 1 in here. So 1 squared minus 1 on minus 1 would get me 0 divided by 0. Okay, and I would think that this is undefined. Okay, so I'd start to wonder, well, what's going on there? Is there actually no limit? What does this even mean? So in this scenario, I'd probably go back to my table of values, okay, and try and approach 1 from below and approach it from above and see what actually happens as we get closer and closer to 1. Okay, so in here, I'd start by substituting in 0.9. So 0.9 squared minus 0.9 divided by 0.9 minus 1, and find out what that is. That gives me 0.9. And I'll do the same thing for these other 3 values of x. What it appears like happening is when I come from below, it seems to be getting closer and closer to 1. Okay, and when I come from above, it seems to be getting closer and closer to 1. Okay, remember, I'm undefined at this point. Okay, but looking at this table, I can still make the statement that the limit as x approaches 1 of x squared minus x on x minus 1, okay, equals 1, okay, from my table. I don't want to be using tables all the time, and this is probably the key learning of this lesson, is that we can do some little tricks with factorization to find these limits where substitution doesn't work. So I'll have a go and see what I can do with substitution. I'll rewrite the question. Okay, and I'll look on the top line of this fraction and see if I can find a common factor, and I'll find that the x is common on both terms. So what I'll be able to do is take out that factor of x, be left with x minus 1, and I'll recognize now that I have a common factor on numerator and denominator, so I can factorize these two. Okay, I just need to be careful that x doesn't actually equal 1. Otherwise, I wouldn't be able to do that cancellation because I'd be dividing by 0. Okay, so generally when we're doing these factorizations and cancelling, we need to note that it never actually equals 1. Okay. So from here, my limit is now just the limit as x approaches 1 of x. Okay, and now I can substitute in the value of 1 into x, and I've shown that that limit is equal to 1. So notice that this limit sign, I've carried it down all the time until this last step where I actually substituted in the value. Okay, it might be interesting to graph this to see what it looks like. So I've got it in my graph. If I draw it, I'll see that at x equals 1, there's actually a hole in the function. So if I draw a box around this to look at it a bit closer, we can see definitely a gap in that function, which is where I had my point that was undefined. But we can see that as we get closer from both sides, it approaches that value of 1 on the y-axis. Okay, so from here, have a go at these questions, okay, using this same layout style all the time. Good luck.